So here on this chapter, we will talk about carbon, phosphorus, nitrogen cycle, nitrogen, water, and oxygen cycle. And here there is a link. You can also you can watch it for more information about the cycles. I will of course talk about the cycles, but I will in this video, in this link, you can find more information about the cycles. I will start with the carbon cycle. So what is a carbon cycle? The carbon cycle, it is one of the biogeochemical cycles in which carbon is exchanged among the biosphere, hydrosphere, and atmosphere. So as you know, carbon dioxide is absorbed by producers to make carbohydrate in photosynthesis. And animals feed on the plants, and as a result, the carbon is passed along the food chain. Most of the carbon they consume is exhaled as carbon dioxide forming during respiration. And at some point, the organism dies, and they are eaten by decomposers. The carbon in their bodies is returned to the atmosphere as carbon dioxide. And when decomposition is blocked in some cases, the plant and animal material can be available as fossil fuel for future combustion. And then again, carbon enters the atmosphere as carbon dioxide from respiration and combustion. You should know that the carbon cycles take about 100 to 200 million years to complete. So there is concern that if humans use up too many fossil fuels, more will not be readily available. So this is the carbon cycle. We talked already about it. So how human activities can affect the carbon cycle? So human can affect the carbon cycle by adding carbon to the atmosphere. So in this picture here, as you can see, we need to have a balance, okay? So here, human activities release a total of 8 gigaton of carbon into the atmosphere each year. 6.3 gigaton per year from fossil fuel, from burning fossil fuel for electricity generation or for transportation. 0.1% gigaton for cement production, as you can see, and also 1.6 gigaton per year by changing land use, such as deforestation and agriculture. However, new plant growth and earthy gas exchange can remove only 4.8 gigaton per year, 2.6% land uptake by new plant growth, and 2.2 gigaton per year ocean uptake by earth-sea gas exchange. So here we can see that we can have an increase of the amount of CO2 in the atmosphere by 3.0 gigaton every year. And here this amount also increases with time. So as we said, by burning fossil fuel, the amount of CO2 increases in the atmosphere. Why? Because burning fossil fuel releases CO2, and also deforestation takes away the plants that would be capturing the carbon dioxide. And both of these actions increase carbon dioxide quantities in the atmosphere and leading to a change in global climate. And the increase of CO2 in the atmosphere disrupts ecosystem and global temperature rises. The second cycle is the oxygen cycle. So the biogeochemical cycles move through the atmosphere, the lithosphere, and the biosphere. And oxygen is the abundant element on our Earth. It is found in the elemental form in the atmosphere to the extent of 21%. So here, as you know, oxygen is released by plants during photosynthesis, and humans and other animals take the oxygen and release carbon dioxide, which is again taken up by plants, and they use this carbon dioxide in photosynthesis to produce energy, and the cycle continues. The third cycle is the water cycle. So here water from different water bodies such as ocean, rivers, even from plants, evaporate, and then cools, condenses, and again falls back to the earth as rain. This cycle, the water cycle, is responsible for maintaining weather conditions. So the water in its various form interact with the surrounding, and it can change temperature and pressure of the atmosphere. Water cycle is important. Why? Because, as you know, 96.5% the total global water on ocean, 2.5% only fresh water, and 1% is also saline water. And from the fresh water can the 2.5%, so 68.6% it is in the form glaciers and ice caps, 30.1% groundwater, and only 1.3% on surface and other fresh water. And here from the surface and fresh water, we can see that there is 73.1% as ice and snow, and 20.1% on lakes, and here some percentages such as in rivers and swamps and atmosphere. How human activities can affect the water cycle: by withdrawing large amounts of fresh water, by clearing vegetation and eroding soils, and by polluting surface and underground water, and by contributing to climate change. And what about the nitrogen cycle? So the nitrogen cycle, it is the biogeochemical cycle by which nitrogen is converted into several forms, and it gets circulated through the atmosphere and various ecosystems such as terrestrial and marine ecosystem. Nitrogen, as you know, it is an essential element for life. And the nitrogen in the atmosphere is fixed by the nitrogen-fixing bacteria present in the root nodule of the leguminous plant and made available to the soil and the plants. So this is the nitrogen in the atmosphere. I guess it's okay. We can, it is fixed as we talked about it. And here, so you should know, the bacteria present in the roots of plants, what it can do, it can just convert this nitrogen gas into a usable compound, we call it ammonia. And after that, the ammonia is also supplied to plants in the form of fertilizers, okay? And this ammonia is converted into nitrate and nitrate. Nitrate, as you can see here, and nitrate and nitrate. And the nitrifying bacteria reduce the nitrates into nitrogen and return it into the atmosphere. And here we can have a cycle. How human activities can affect the nitrogen cycle. Human activities such as fossil fuel combustion and use of artificial nitrogen fertilizers and release of nitrogen in wastewater have dramatically altered the global nitrogen cycle. How about adding acid that contributes to acid rain? Adding nitrous oxide to the atmosphere through farming practices which can warm the atmosphere and deplete ozone. Contaminating groundwater from nitrate ion in inorganic fertilizers, and releasing nitrogen into the troposphere through deforestation. The last cycle is the phosphorus cycle. In this biogeochemical cycle, phosphorus moves through the hydrosphere, lithosphere, and biosphere. How phosphorus is extracted? So as you can see, phosphor here in rocks. So phosphorus is extracted by the weathering of rocks due to rain and erosion. So phosphorus is washed away in the soil and in the also water bodies. And due to rains and erosion, phosphorus is washed away in the, as we said, in the soil and water bodies. So now plants and animals obtain this, as you can see, plants and animals can obtain this phosphorus through the soil. As you can see here, plants it takes from the soil, and then the animals eat the plants. So also animals can take the phosphorus. Why? Of course, to grow. So if you talk about plants and animals. And here microorganism also require some microorganism require phosphorus for their growth. So when the plants and animals die, they decompose, and the stored phosphorus is returned to the soil and water bodies again, which again consumed by plants and animals, and the cycle continues. Okay. How human activities can affect phosphorus cycle? Why? Because we remove a large amount of phosphate from the earth to make fertilizer. We reduce phosphorus in tropical soil by clearing forests, and we added excess phosphate to aquatic system from runoff of animal waste and fertilizers, and contribute to eutrophication. This is eutrophication. It means here nitrogen and phosphorus or phosphate fertilizer is spread on fields to help crops grow. And then the rain causes runoff of streams, rivers, and lakes, as you can see here. So the runoff increases nitrogen and phosphate levels. And what it happens here it can cause an overgrowth of algae. We call it algae bloom. And here you can see a large amount of algae die and are decomposed by bacteria that use up much of the oxygen in the process, and causing plants and fish to die and destroy the ecosystem. Thank you so much.